Okay, welcome back. Sorry, I got cut off there at the end of the last video and didn't get to finish this problem. I didn't know where my calculator was. So we were just finishing up this number 3, the inverse tangent of cosine pi over 3. We got to the point where we knew that we were looking for theta, where tan theta is a half. Okay, so we need a calculator to find theta. We don't have any technique for finding an exact value for theta. I won't try to fool you with any of these. Like if it's a calculator problem, I'll say use a calculator. If it's by hand, I'll say you must do it by hand without a calculator. I just wanted a few examples that we're going to see, and we're going to see that in the next video too, where we just have to call on a calculator to help us out. So what we can do is, what we're trying to do is go back to an angle from a value of the tangent function, and we can also just say here that we're trying to find theta, which is equal to tan inverse of cosine of pi over 3, which is equal to tan inverse of a half. Really, the finding a value for tan inverse a half is what we're all about here. And so I'm just going to pull out my cheapo calculator and enter in 0.5 or a half, and I can use the shift key to access the inverse trig functions on this calculator. I'm not, of course, your calculator may be different, and I also need to think about whether I want to be in degree mode or radian mode. We've been working with radians, so I'm setting this calculator to radian mode, because the thing is, the output here could be in degrees, could be on radians, depending on what mode my calculator is set to. We've been using radians only for quite a while here, so I'm going to use a radian output and do second tan inverse, and I'm going to have to round off also. It's giving me a decimal form, 0.4636 radians is the answer to this problem. Again, I need a calculator to help out. If you accidentally use degree mode, just say degrees. Make sure you put your units on the value you find. If you're uncertain whether it's called for to use degrees or radians. Okay, there's just one more thing I want to mention here, is that posted in Canvas is a chart that I hope you'll refer to. You might even want to print out. So it's a sheet that has sine, cosine, tangent, the restricted domain of sine, cosine, tangent, and then the corresponding inverse function. So this sheet sums up the graphs of the inverse trig functions that you are responsible for. I might ask you to graph inverse sine, inverse cosine, or inverse tangent on a test, and here they are. These are the only inverse trig functions we're going to discuss. We are not going to discuss the inverse secant, cosecant, or cotangent at all. And so that's it. We will have one more video with several more odds and end problems about inverse trig functions.